Thank you, guys, and welcome. Um, this is Saúl. I'm Aniol, as Michael introduced us. And today we will be talking about running your own node and why this is important to support the Bitcoin network by enforcing the consensus rules. I want to start by saying that please don't hesitate to interrupt and ask many questions. So it's not only Saul and I talking, and we make it a bit more interactive and fun. Plus, I'm sure there are some people in the audience that are very knowledgeable. So please just correct all the mistakes that we will be making.
We won't get mad.
No, we take feedback pretty well.
Can't promise, but
We like to start with a quote here, very much relatable to the topic, which is whether you know it or not. Every time you make a Bitcoin transaction, you are using a node. So this is either yours or someone else's, and that leads to the very famous saying. If you know in the Bitcoin world, probably you've heard that before. Uh, don't trust, verify. Dude, uh, on the wheel. But you need to stay quiet, huh?
yeah, you can take a Coca-Cola or something, a Coca-Cola only.
Yeah. Cool. Uh, just to walk you a bit through the content, what we will be taking today, it's what is Bitcoin, what is a node, why should I or you run a node, what kind of nodes are out there, and how do I run my own node. Yeah.
Any questions?
And now I hand over to Saul.
Yeah. So, I mean, let's start then with a simple question, right? So, what is Bitcoin? And here, I mean, we can have help from the audience in one sentence. What is Bitcoin? Do you know?
Yeah.
Okay, a
Good.
cryptocurrency. Any other opinion or statement? The first cryptocurrency. Right. Yeah, I mean, all of these things yeah.
Okay.
You had an answer? So it's something for investing.
Yeah.
Right. So some people might say it's an asset, or you can say it's like gold. Some others say it's a cult even, and which could be right. But other people could say it's just money, and probably the best one there has ever existed in history, right? But in essence, it's just a ledger. So by a definition, it's basically a peer-to-peer network, which is made of computers and or nodes that run a software. And basically, this software like run a proof of work consensus mechanism which validate transactions. So it's just basically a ledger which is propagating information, the same truth throughout all the network, and it's just confirming uh, who has access to which funds. In some way we could say that Bitcoin doesn't really exist. There is no Bitcoin. There is no thing in your wallet. It's just basically a ledger that has some recording of transactions. And if you own a wallet, you have a way to sign the transfer of ownership or to move something from one address to another. So basically, this is Bitcoin, right? And then the next question is, so what is a node? And a node is, in a simple essence, is just basically the Bitcoin software. So it's just basically a computer or that is running the network, right? And what does it do? Well, a node will host the whole copy of the blockchain, entirely or partial, but so basically it runs through all the transactions. One could say it's like a database. It provides some routing, so it's a network that propagates information between one another. It could even mine, so it could do some mining, and it could provide some wallet services, so a way to transfer funds between peer to peer. And one might wonder, does it do all of this, or how does it work? I mean, maybe many people didn't really have stopped and thought what was exactly a node, right? And so for this, let's go a bit towards the history on how it started. And when in the beginning, when Bitcoin was released, here I will refer to basically Bitcoin Core, let's say. You install a software in your computer, and this software was basically a node. We also had a wallet, and you can send and receive transactions. And you had basically a feature in the wallet where you could decide to activate for mining or not. So everything came in this one software, which was basically the whole package, right? But then it was hard to start abstracting things in order to be able to have it on the mobile phone. So what started to develop from there is to abstract little by little, right? And then maybe it became like some mobile wallets, which basically were able to send and receive. But sometimes we don't think about this, but the wallet is connected to a node. So every transaction that we do from this wallet is basically you're sending so the node is basically connected to the wallet, even if we don't know it, right? If you download one from the app store, it will already by default be connected to someone. And whenever you send a transaction, it will propagate your information to all the network, right? And then like the nodes start to also try to get like abstracted in order to be able for people to run it easily and connect to your own node. So what do I mean here? In essence, the wallets which provided the service that you can download from the web started to see that this was basically a, a desire from the market where you could have your own node and you wanted to connect it. And since it wasn't maybe that easy, they started to do abstraction so that you could connect and start having, let's say, some privacy or to not trust and verify, right? So how does this kind of work if we want to see it on an image? Basically, it starts with a network. Everyone, let's say, downloads Bitcoin Core in their laptop and they connect and they run the network, right? Some of them might decide or not to start mining. And so some of them are basically mining. And whenever a transaction gets issued, it's shared to all the whole network. The miners pick some of them when they find the when with the proof of work when they find the valid block, then they could issue the one that they want based on fees. They could maybe do any kind of arrangement that they want. And then the wallets came about. So basically, let's say in this example, two popular wallets, Blue Wallet and Green Wallet. And in the beginning, when you download the app, you connect to those wallets. So whenever you were sending a transaction, it's just as we mentioned, the wallet was taking care with the node to propagate that into the entire network. And then they came the node implementations, which allow you to have your own node in a simplified way, let's say. And then we have these like shadowy supercoders, how sometimes they are called, where they could be completely sovereign and try to basically be their own bank completely. So why should we run a node? When with this, Aniol will continue.
Okay, guys. So let me put this question forward to the audience then. Let's see if we come up with some reasons why we should all run a node. Uh, Yay. Nice. There are more reasons. Come on. No?
No, no one.
be. I mean, I'm not aware if that's the case, but could be. Sorry. Yeah, no,
I
we
mean,
can maybe
if you're
touch
a
a bit.
mining node, then yes. Otherwise, on a normal node,
And if
that
you
wouldn't be the
run
case.
Lightning, then you could make a bit. But yeah, Bitcoin node by default is not profitable. Yeah. Exactly.
Yeah.
It's about privacy, like Saul said before. Yeah. Paranoia. Good. Yeah. So let's start with the first point, which is the first thing Amadeo said, and to me at least personally is the most important, is to enforce to make the network safe by enforcing the consensus rules. And here I want to mention something that I believe is really important, and probably here we know, but like not many people know, and it's the fact that uh, it's nodes that enforce the consensus rules and not miners, right? Um, so, cheers. So, where was I? Yeah. So consensus rules. So what we like Saul mentioned a bit before, and I'm sure you are quite familiar with it, but nodes are basically the propagators of the truth, right? When a transaction is created, a node will validate it, right? It will be sent to a node will validate it. Only if this transaction is valid, it will be propagated to the rest of the nodes in the network, right? Some of these nodes in the network will be mining nodes. So they will take this transaction and they will mine it into a block. They will solve the algorithm and then they will put the block onto the blockchain. And then this block will be also transmitted to the other nodes. And the nodes will first validate the block and only propagate the block if it's valid. So this is very important because at the end of the day, it's nodes who decide what to propagate and what not. So nodes have really the power here. Then of course you could argue, yeah, but you just said that mining nodes are also nodes. Yes, and that's a very good point. But the point here is that not because a node is a mining node, it has more power, more voting power than the rest of the nodes. So all nodes are created equal. So what's the point here? What we really want is to have as many independent nodes as possible so they cannot be controlled by an individual or by a group of individuals that is planning an attack, control nodes, and then change the consensus rules to their benefit. So this is what we don't want. Yeah? Any questions here? Or good? The second point is I should change the title to paranoia here, like you said. I think that was a bit spot on, but let's call it privacy for now. It's about your privacy. Uh, Also, Saul talked about it before a bit. Uh, Basically, if you don't have your own node, every time you receive Bitcoin or send Bitcoin, you need to connect to a node, right? So you connect to someone else's node. So what happens here? This third-party node will have access to your IP address and therefore will know all the Bitcoin addresses that you have ever used, all the Bitcoin transactions that you have ever made, and all the Bitcoin balances you have ever had. So how can we fix that? There are ways, like for example, a way could be to connect through a VPN, so we could hide our IP address. Uh, and another way is what we're discussing today: just run your own node, so you can verify your own transactions. And I want to mention a third point here, which I believe is really important, and it's about size. So when we say that size matters, does anyone know what we are referring to? What I'm referring here more is the block size, and this is why I made this little drawing. Um, I don't know if you guys are familiar with something that is called the block size war, which happened between 2015 and 2017. And The thing is, like a block in the Bitcoin blockchain has a capacity of 1 megabyte, right? And therefore the amount of transactions that you can add into that block is limited. So back at that time, there were some proponents that wanted to increase the size of the block significantly for the sake of scalability. So we could add many more transactions in each block, and therefore many more transactions in total in the long run, right? But I mean, like first you might think this is beneficial, but what is the problem that can come with that? Amadeus? Exactly, exactly,
Exactly.
exactly. So
And
yeah,
to add to this point, because I find it amusing, like if it becomes super expensive, who ends up running all the nodes? The miners, which will be the problem. Then they have the entire power, right? If they mine and they are the only validators, and this is basically what we don't want.
exactly, exactly. So the point here is that uh, just to improve scalability, we are compromising decentralization. And I think this is something very important to keep in mind. One of the Bitcoin core's value proposition is the fact that it's decentralized and it's immutable. And this is thanks to many nodes which are independent and all of them enforce the consensus rules. If suddenly it becomes really expensive and you need a lot of storage to run your node, there will be many less nodes. And as Saul said, for example, miners could take advantage of that and just control a sufficient amount of nodes to change the consensus rules to their favor. So this is what we don't want.
I have to ask a question.
Yeah.
I actually don't understand this reasoning because if you change the size of the block to something bigger,
Hmm.
why does it affect how much hard disk we have? Or even if you have small block size and you have a lot of blocks, we have big block size taking up the same amount but less blocks.
But
How does that
yeah,
affect the
Uh,
hard disk situation?
the point is that blocks, according to the difficulty adjustment algorithm, blocks are mined every 10 minutes. So if you increase the size of the block, they will keep being mined every 10 minutes. So
yeah,
then the size of the blockchain will increase exponentially, right?
and
Okay.
it's natural for a miner to want a bigger block size because that
More
means
fees.
more fees. If
Ah,
every transaction has a fee, then it's better for them, right? But if right now you haven't mentioned, I think he's about to mention the size of the blockchain is quite big by being 1 megabyte or two
Exactly.
megabytes per block. Imagine if it's 4 or 8, then it will
It's
become
exponential.
exponentially bigger,
Yeah.
right?
I see. Okay. Yeah.
Yeah. So just coming to Saul's point, the current size of the blockchain is 420 gigabytes. Gigabytes. I checked it yesterday. So yeah, this is still okay, because you can have it at home with the 1 terabyte of solid state drive. But just by increasing a bit every block, then of course the total size of the blockchain will just increase exponentially, and that will be very expensive to run at home. Um, uh-huh. You are you are advancing like I'm getting there. It's
Yeah.
good thinking, good thinking. Any more questions here? We continue. You should.
So the block size, who is controlling the scale of that? You say 1 meg per block, and now it's increasing. How is that being controlled?
Yeah.
What's kind of like governing the size of the blocks?
So this is the code, right? So there is a code that was basically implemented by Satoshi Nakamoto back in 2009, and the size of the block was 1 megabyte, and it has been like that. But in 2015, that there were some part of the developers that said like, okay, we should change the code and increase it to like some people say 2 megabytes, 4 megabytes, or more, right? So then what happened is that even if that's the beauty of Bitcoin, right? Not because one developer has a magic idea, he cannot just implement it. The thing is, like, I will also talk about this, or I can actually say it now, but like, all the nodes decide what the rules are, by deciding which update or which version they are running of the Bitcoin core, which is the software that the node uses to connect to the blockchain, right? So then, let's say the developer says like, now the blocks are 2 MB. Then if you don't agree, you will not update your software to the new version of the Bitcoin core, because then you know that you are accepting these 2 MB, right? So you stay to the old one, and that's what happened. The nodes are like, no way, we are not going to update that, and therefore we kept with 1 MB.
So there's, in order to not split the chain in different ones, there's something called backward compatibility, which there are some changes that could be done, which if people do not change their node, it should still run and be okay. But changing the size of it, that's like a big part. So the other nodes won't recognize it. Yeah.
Mm, good. Now I'm coming to your question. Types of nodes. Uh, I want to start here by saying that I will talk about different types of nodes, but what is clear or what is important to know is that all nodes, no matter the type, have one very important function, which is a routing function. So all nodes will receive blocks and transactions, and they will propagate, if valid, they will propagate them to the rest of the network. We could say that this is the main function of a node. Then we start with the first type, that's a full node. So a full node basically is very simple. As the name says, it stores or hosts the entirety of the blockchain. So here, all the 420 gigabytes are stored in that node. If it's a computer, a Raspberry Pi, whatever. But then we also have what we call lightweight nodes, or SPV, which stands for simplified payment verification. So in here, what happens is that the node doesn't store the whole blockchain, but instead it only stores the headers, the block headers. So that actually takes much less space than the 420 gigabytes.
Keep in mind that for this one, if you spin one of these nodes, the node from scratch has to find a full one, run everything from scratch to validate that it's basically the truth and that the rules were enforced. And then, I mean, doesn't store whatever it doesn't need, but it has to find the truth in the beginning.
Yeah, exactly. So in a way, we could say that full nodes are always needed. There
Mm.
needs to be full nodes because the lightweight nodes trust on the knowledge that the full nodes have. And then the famous mining node. The simplest way to think about it is just, this is a regular node, but with mining capabilities. So basically, it has mining equipment, which is called ASIC, which is application-specific integrated circuit. So it's a very specific equipment that is designed and created just to solve the proof of work algorithm, to like use a lot of computational power to find a value that actually solves the algorithm, right? Um, it's also important to know that what mining nodes do is they compete among themselves. So miners are always in a constant competition, because the first one to find the solution to the proof of work will be able to mine the block and therefore get all the fees from the transactions that are in the block, plus the reward for having mined a block. And also mining nodes can either be full nodes, but they can also be lightweight nodes. If a mining node is a lightweight node, then they belong to a mining pool where they will also split afterwards the reward if they successfully find the solution to the proof of work. And last but not least, I think that's a very interesting concept to talk about. A bit confusing, but a node is a wallet. So a node actually can create and receive Bitcoin transactions, and it can also uh, store the keys to be a keychain, right? What's the difference between a node and a wallet? Basically, what a node does is to track the blockchain's global state, whereas a wallet, if it's your wallet, will only track your transactions. So information will always be fed from node to wallet, because for a wallet to track your transactions, it needs to have access to the global blockchain state, right? Yeah, And yeah, an interesting fact here as well is that currently there are approx under 15,000 listening nodes on the Bitcoin network. By listening nodes, I mean nodes that are reachable, and from those, only a few hundred are mining nodes.
And with reachable means that if they're on Tor, probably you cannot see them.
Yeah.
So there's some nodes that are not able to be seen, as far as I understand, which is basically ours in
Uh-huh.
some sort of way. Like ours will be on their Tor.
So then you would say that it's safe to assume that there are more nodes than the reachable ones, right?
Yeah.
Okay. I also like to mention like the reason why I chose those icons for a wallet is because I think it's a bit misleading to show a wallet, because what a wallet does basically is to create, send and receive transactions and to sign the transactions, and also it holds your keys. That's it. So it's not like, as Saul said first, Bitcoin doesn't exist, right? Bitcoin is just a ledger. Okay, how do I run my own node? I start here with hardware requirements. This, what we show here first, is what Saul and I are running at home. It's not the only option. There are many that I will show later on as well. But we believe that this is a pretty straightforward and simple way to run your node. So what you need in this case basically is a computer or a Raspberry Pi. For those of you who are not familiar with what's a Raspberry Pi, it's just kind of the simplest form of a computer, we could say. And here we wrote 8 gigabytes of RAM. This is to be on the safe side for max performance. With 4 gigabytes, it would also work. As I mentioned before, the current size of the blockchain is 420 gigabytes. So with 1 terabyte of solid state drive, you are good to go. Because also, if you run a node, you need to think that you want to run it for many years, right? So you also need to allocate for the fact that the blockchain will keep increasing, right? Then 16 gigabytes micro SD. In here, basically, is where you will install the software that will allow your node to connect to the Bitcoin network, right? So, for example, Bitcoin Core. And then that micro SD will go into the Raspberry Pi. And last but not least, you need internet and power supply. Ideally, you want to run your node continuously because that's the best way to support the Bitcoin network. But I also want to mention here that if your node is down for a while, it's not a problem. When you reconnect it, it will just catch up with and download the missing part of the blockchain that has missed during the time that it was down. And then I finish this one with a napkin calculation, which I hope it's right. But I took the last 12 months average energy price in Malmö, and assuming the consumption of a Raspberry Pi, to run it 24/7 for a whole year costs 45 SEK. So it's like a kind of a joke, right? Now energy prices have increased, so we should also take that into
So 100,
consideration,
100
But like
kroners.
even if it's twice as much, it's 100 SEK per year. Uh, so when I installed the node at home, I had a chat with my girlfriend, which I had to convince her that it was not that expensive to run it. It took me a while. uh, then once this is done, it's also time to choose implementation and connect it to your wallet. So basically, there are many companies nowadays that offer software solutions that allow you to run your own node, right? So I'm going to show some of them, but to start, to follow with the example that we had before, this is Umbrel. So once you have assembled all that, the Raspberry Pi and so on, then you just connect to the blockchain, and then you have a very user-friendly uh, software interface that allows you to interact with your node. We call it that it's a bit DIY because you still need to buy the parts separately and you need to do some assembly at home, even though it's very simple and it's very well explained. So it's up, and anyone can do it basically, right? However, there are other solutions as well that we call plug and play. That will be, for example, a company called Nodal, and is what the name says. You basically receive the equipment at home, you just plug it, power and internet, and you are good to go. And then, of course, there is the old school, just run it on your on your computer terminal. Uh, yeah. And then, of course, let's not forget the most important point: why we are doing this, right? So once everything is connected, then your node is updated with the blockchain, and you are able to talk to your node. Then it's time to connect your wallet or wallets to your node, right? So you can start verifying your transactions with your own node, which is one of the reasons why we have our own node. Any questions? Good. So, Saul.
So another part of running the node, it's that basically, I mean, Bitcoin is just, as we mentioned, a computer, right? So it's programmable, and as we stated, it has some size of the blocks, and it tries to ensure some decentralization that everyone can run one of them. So the idea is that every solution can be built on top. And with this, I mean, having a node can allow you or give you access to run applications, right? And there's different kinds. It could be like wallet applications. This is here. I mean, to be honest, if you open Umbrel, you'll see a list of probably 60 different ones. I don't know what all of them do, but for example, I took an example of different classes or segments, and one is the wallet servers or applications. And this is an example of Samurai Wallet, which will allow you to have access to some wallets that will grant you the optionality of mixing your funds with other people and then receiving the same amount on a new address, but you are basically validating this without any other node, which means that you can gain some privacy back because if you buy Bitcoin, let's say you buy it from an exchange, then the exchange tracks this person who registered with his name and passport and everything has this address. If somehow something illegal happened with this Bitcoin, then they will be able to easily track. If you if you then send it to a friend, or if you send it fully to another address, the deniability is quite low. Probabilistically, you can never really guarantee that is yours, but probabilistically, if you send all of the funds, it will be like 99% probable that is your same either not your same wallet, but another address that you control. If it starts to be split in different ones, then the probability reduces. But if then it loses track because it got mixed with many, that's basically an application that exists and it has to run on some basically independent servers joining forces, right? Which has, of course, its trade-offs. Then it allows you to run Lightning, which is basically a second layer on top of Bitcoin, which will allow you to do instant transactions with low fees. The main difference here that we could think of is that in here the fees are not not taken by the miners, but the different nodes that are existing on Lightning. To enter Lightning from your node, it's basically you have to create channels of liquidity, and then if I want to arrive to someone else, it might hop on some other people. It will transfer through other people, and each party will charge a percentage of a fee, and this percentage could be super low, which will end up you can end up paying like zero point 0.1 or even less percentage of the transaction, which is nothing for small payments, but but for big payments it will be better still to use on chain. Then we have finance applications, and this is an example BTC Pay server, which will be the same case of having a node, but then you specifically install that application, and you'll have to have a little screen on it, and it will basically become a point of sale service. And then you can have connected in the internet and just download the whole list of transactions, the price it was at that moment, and you can like do your taxes and have immediately a way to receive Bitcoin in your business, let's say. And we have different explorers. Today I had this conversation with a friend, basically, or yesterday. Well, basically, when you make a transaction, you can click on the transaction and you can see where it comes from, and you can basically start digging where that address, how much Bitcoin that address had, or what happened before that transaction, and all of this you're relaying on some other people's node. But this same, basically, in this example, it's called mempool.space. They also have the application where you are allowed to do it yourself, and this will run in your little Raspberry Pi, and then it will take the information from your node. So then you guarantee that what you're seeing there, it's correct. So the takeaways here.
Yeah, it should. So we basically try to summarize a bit the whole thing in three main takeaways, which we believe are maybe the most important that you should take home today. First of all, a node is pretty simple. It's a computer which is connected to the Bitcoin network. Not more complex than that. Then every Bitcoin transaction and every mine block gets propagated by and to all nodes, because that's basically the primary function of a node, is to propagate the valid blocks and transactions. And last and most important, the best way to minimize trust is to validate your own transactions through your own node.
And with this, we want to close the presentation with a nice quote that we find in the internet from Friedrich Hayek, which it says, "I don't believe we shall ever have good money again before we take the thing out of the hands of government. Since we cannot take it violently, all we can do is by some sly roundabout way introduce something that they cannot stop." And essentially, this is the only way to have money that cannot be stopped. That's the best case of a blockchain, and it only works if it's really decentralized. So Bitcoin. Yeah. Thank you.
Hey guys.